for today's lecture was meant to be map skills, and because I thought, okay, everybody knows how to use Google Maps, I just changed it a little bit and did sky maps, which are perhaps a little bit more interesting. So do you know anything about astronomy or sky maps?
No.
Okay. Then let me just share my screen. Can you see the screen?
Yes.
Perfect. So astronomy is obviously a very big topic, and it relates a bit with physics, but for the amateur astronomer, as they call it, observational astronomy is the first step you take to understand how the universe works and how you start seeing things. That's why sky maps are such a valuable tool. So that is a sky map. It's a sky map of the whole sky. I mean, honestly, it looks like a bit of gibberish, a lot of names and constellations, and probably 99% of those names are completely useless in the sense that you will only ever read them from a book and just use that book to guide yourself. You don't need to memorize anything. But some bits you need to be very confident with if you go into the night sky and want to explore a given part of the sky in a given country like Guatemala, Chile, Cambridge, blah, blah, blah. So this is a very general map, but basically this presentation and everything else I'm doing is giving you the skills to grab this map and be like, oh yes, I'm here, I can use this bit and this bit not, and well, I can read this at this time of the year and this time I can't, etc. So sky maps are based on a system of coordinates called polar coordinates. Have you heard of the polar coordinates before?
No.
Okay, but have you heard of the Cartesian coordinates, the x, y, and z? Yeah. So I have a very simple question to you. I know you're inside a house, so think about where the light switch for your house is. Okay. Now imagine you're at the point 0, 0 here. Think about the position of the light switch in terms of meters, imagining that you are in 0, 0. Where do you think the light switch is approximately?
Like in meters or in the graphic?
Meters.
Like
an estimate.
1 meter.
1 meter in x coordinate, y coordinate, z coordinate.
So it would be like in x coordinate, like 3.
Mm-hmm. 3. Okay, and in the y coordinate,
it will be like 8.2.
Perfect. So that was hard. I mean, it's not like you just the number popped in your mind and you were like, oh yes, I know. No, you had to think about it. Okay, and in science we don't want to think about things. We want to make things as systematic as possible. Now, how would you usually tell somebody where the light switch is? You would just point in that direction and see like it's there 5 meters from there, about right? That's much more simple than what I just made you do. And that's the core idea of polar coordinates. What you do with polar coordinates is you have a point and you point in that direction and you say how far it is from where you are, and that's it. No more trouble, and that's way easier, right? Right. And the exact same idea occurs with stars. So stars are points, and if we bother to do it with polar coordinates, it would be a mess. That's why we don't do it with Cartesian coordinates. It would be a mess because they're very, very far away. So you cannot be precise about where they are. But with polar coordinates, it's different. You just point in that direction and you say, oh, it's very far away. It doesn't matter because it's in that direction. Okay, and that direction, you just point a telescope and you can see it. Okay, so you don't worry about distances. Now, I put a polar coordinate. It's actually more astronomical. It's not necessarily a pure polar coordinate. It's called a horizontal system because you're basing yourself on the horizon. Okay, so imagine you're in the night sky. Then the horizon is the ground, right? Everything that is dark is the earth, so you don't care about it, and the part that is white, it's the sky. Okay. The only thing you need to worry about this is that you need to be facing north, and the point that is right above your head. So if you look right above you, it's called the zenith. And those are the only things that we use nowadays. It's a very bad system because it depends on where you are. Okay. Because I'm in Cambridge, I'm in the northern hemisphere, much more north than you are. And that means my zenith is different from yours, and my sky is different from yours. So if you draw your own map sky using a computer, I wouldn't be able to understand it very easily. I would need to think about it a bit. I would need to translate everything, do some extra calculations. Again, a mess. We want things to be much more easy to understand. And well, that's this part is basically what I just said. Okay, so um, what you see in the sky depends on your location, or more exactly, the latitude. So how you up, how high you are, and it depends on the time you're up or your longitude. So my time is like 2 p.m. here. What's your time there?
7 a.m.
Yeah. So like if we go back in time 7 hours, you will be in the night. And if I go back 7 hours, it would be like morning, so I couldn't be able to see the stars. Okay. So our skies again are different. Now I have a YouTube video. Tell me if you can. Wait, I'll just share the new video I had for you. Okay. Can you see the video?
Yes.
Okay. It's a pretty basic video, to be honest. So again, with time, the night sky changes a lot. It changes very fast. So it does a complete revolution in 24 hours. That's why I say it really changes very fast.